This is the third video about limiting reactant. Let's have some more examples. If a sample containing 18.1 grams of NH3 or ammonia is reacted with 90.4 grams of CuO, which is the limiting reactant, how many grams of N2 will be formed? So we have this chemical reaction, 2 ammonia plus 3 CuO results in N2 plus 3 Cu plus 3 water. And the molar mass of ammonia and CuO are given. 17.03 grams per mole, 79.55 grams per mole. So as you see here, the amount of ammonia and CuO is given. So we have the molar mass, so we can divide it by molar mass, each of them, to find the number of moles. So here we have 18.1 grams. We have this ratio to find the number of moles. So the number of moles of ammonia is 1.06 moles. On the other hand, we have CuO, 90.4 grams. If we divide it by molar mass, which is 79.55 grams, we get number of moles of CuO, which is 1.14 moles. To determine which one is the limiting reactant, we use the mole ratio for CuO and ammonia. So this is another approach to find the limiting reactant. So we write one of them, 1.06 moles NH3, and then we go here and we see that the molar ratio of CuO and NH3 is 3 and 1. It's 3 and 2. So it means that these are equivalent, stoichiometrically equivalent. So 2 moles of ammonia must react with 3 moles of CuO. So if we write this molar ratio here, we will see that we need, for this amount of ammonia, we need 1.59 moles of CuO. So if we have less than this amount, it means that the limiting reactant is CuO. So let's do it like that. The molar ratio of CuO and NH3 required by the balance equation, it is 3 to 1, as we saw here. As we saw here, we said the molar ratio is 3 to 1, so 1.5. Now, the molar ratio, the actual molar ratio, based on our calculation, is 1.14 divided by 1.06. So it is going to be 1.08, which is less than 1.9. So based on that, we can say that the limiting reactant is CuO, because the ratio is smaller than the required ratio. Let's have another example. So here we can find the number of moles of CuO before we go for the next example. So because CuO is the limiting reactant, we must use the amount of CuO to calculate the amount of N2 formed. So that's the actual amount of CuO. So 1.14 moles CuO times 1 mole of N2 divided by 3 moles of CuO. If I go back here in the example, 3 moles of CuO results in 1 mole of nitrogen. That's what we need to find. How many grams of N2 will be formed? So we have this, the actual amount of CuO, 1.14 moles CuO, and we know per 3 moles of CuO we will produce 1 mole of N2. So with this amount we can produce 0.38 moles of nitrogen. Then we can multiply it by molar mass to find the grams of nitrogen. So 0.38 moles N2 times 28 grams N2 divided by 1 mole of nitrogen is going to give us 10.6 grams nitrogen. These two cancel each other and the remaining unit becomes grams of nitrogen. Next example. Suppose 68.5 kilograms CO or carbon monoxide is reacted with 8.6 kilograms hydrogen. Calculate the theoretical yield of methanol if 3.57 and 10 times 10 power 4 grams methanol is actually produced. What is the percent yield of methanol? So that's the chemical reaction we have. Hydrogen plus carbon monoxide is going to give us methanol. So the amount of CO and hydrogen is given. So first of all, we need to find the number of moles of each of them and find which one is the limiting reactant, and then find the theoretical amount of methanol produced. So we have 68.5 kilograms CO. First of all, we need to convert it to grams. Then we divide it by molar mass to find the number of moles. On the other hand, for hydrogen, we do the same thing. Convert it to grams, then divide it by molar mass, find the number of moles. To determine which reactant is limiting, we can again write the ratio, mole of hydrogen divided by mole of CO. It must be 2 to 1. Based on our chemical reaction, we have it here, 2 to 1. In reality, the actual amount we calculated here, 4.27 times 10 power 3 divided by 2.44 times 10 power 3, which is 1.75. So since this result is less than 2, we can say hydrogen is the limiting reactant. So as you see here, the hydrogen is the limiting reactant, so we need to stick to this amount. We have this number of moles of hydrogen, and we can say based on 2 moles of hydrogen we will produce 1 mole of methanol. So 4.27 times 10 power 3 moles of hydrogen, and we can write this molar ratio. We can say we can theoretically produce 2.14 times 10 power 3 moles of methanol. Then this number of moles we can convert it to number of grams by multiplying by molar mass. So molar mass of methanol is 32.04 grams. So mole and mole cancel each other, and then we can find the amount of methanol produced theoretically. Then we can find the percent yield, which is actual yield in terms of grams divided by theoretical yields in terms of grams times 100. So the actual yield, we have it is given here, 3.57 times 10 power 4. We write it here, and the actual and the theoretical amount, we have it here, 6.86 times 10 power 3 grams methanol times 100% results in 52%. So that's the percent yield.